Hello everyone, welcome back to the part 2 of the end of term 3 exam videos. I am Justin D'Souza, your math teacher, and this is my channel Best Math. If you're visiting this channel for the first time, welcome, warm welcome. And this is my channel where you can find math videos, explanation videos, tricks, shortcuts of different mathematic problems. If you have found it useful, please do subscribe to my channel. It would mean a lot to me. And also, I want to thank all those who have subscribed to my channel, all those who shared my channel and like the videos. Thank you very much. And please do continue to support me. Now, in this part 2, we will be going on with the question number 11 to the question number 20. We will start with the question number 11. It's area between the curves. Now, if you're looking into this, you will recognize we had solved the similar problem in the part 1 as well. If you're all new to it, I would suggest you or highly recommend you to go to the part 1 first, because all the explanation videos of the part 1 are very useful if you watch in continuity, because then this will be much easier. Nonetheless, I'll be explaining this thoroughly over here now. To find the area between curves. Now we have two curves over here. X is equal to g of y and x is equal to f of y. One is in pink and one is in blue. Now the limits are given from C to D. How would you find this area? The area is given by, from the limit, whichever is considered. In this case, it's C to D. You need to find the right function, the right side, that is f of y, minus the left side. That's it. That will give you the answer. Now, it's basically the right function minus the left function in simple terms. So now, over here, this function will be given and this will be given. But now there is one thing. Okay, it's so simple, right? But generally, if you remember, your questions will be in terms of y is equal to x squared plus 2 or y is equal to x plus 3, something like this, isn't it? Now, what do we do? Because here they're asking for x. And how do we understand where or which side to take, or, it's very complicated, right? Let me make it easy. Now, if you have this x and y axis, sorry for those axes, okay, x and y, imagine you have a line like this and a curve like this, a function like this. These are the functions. And you have to find the area between them. Which is the axis that comes, parallel or exactly in between them, not across, in between. If it's like this, you see the x-axis is in between them, isn't it? So then we will have to keep the functions with respect to x, that is f of x or g of x. Okay, so that means this is the example, say this one over here. That would be the best example, because now the function at the right side, y is alone, leave that is the function. What is the given over here? X squared plus 2. If it is across the if it is across x-axis and x-axis is coming in between, you must always have your equations like this. But now look over here, it is f of y, and you see this, sorry, this is the y-axis and the y-axis in between the two functions. Then you need to have the function with respect to y, that is g of y or f of y. What do you do? Now, if this is your equation, take everything to the other side and keep x alone. That would mean take this to the other side. Y minus 2 equals x squared. X squared, I'll bring it to the left side, just swapping the positions. Y minus 2. Take square root on both the sides. You will get x equals root of y minus 2. This is the equation which we will be using. Similarly, over here, it would be x equals y minus 3. This would be the equation we will be using. So I hope you understand the difference on when to change or when to swap. So it depends on the figure. Okay. Now we will see the problem. You will understand much better. Say, for example, over here, we have find the area bounded by the graphs of y equals x squared, y equals 2 minus x, and y equals 0. So this is it, right? First, you need to understand a little bit of the function by graphing. Even if you do not graph, you can solve it, but graphing makes it much easier. Now, you have this graph over here. Y equals x square. What does that mean? Okay, I will just draw a rough graph. Y equals x square. I know it's a parabola. It will go something like this. Brilliant. What about 2 minus x? That means, see now it's going like this, right? Minus means it's going downwards. You need to draw a line like this, something like this. Okay, so this is the basic understanding of graph. Why? Because over here minus is this, so it will go downwards. This is parabola upwards, and y is equal to 0. That means all the values above 0. See, this is the region of solution, all above. I mean, see now when you practically draw them, don't not above. Now it's just this is the line, right? Find the area from y equals 0. That means this would be the region, right? This is the enclosed region, not this one, because all the three must be considered. So over here, this is the region that will be formed. Okay, that is the basic understanding. Now you can see over here, it is just like that, x squared. This is the 2 minus x, and y is equal to 0. Now, if you look closely, you will understand which axis is along this. That is the y-axis over here, isn't it? If it is x, yes, x also can be solved. But you know there are two separate limits. From here to here, it's a different function. For x, it is upper minus lower. See, upper minus lower, upper minus lower. Whereas for y-axis, if you're solving with respect to y-axis, look over here. Right function minus left. Class, that's it. So this is the thing. Now we will see, after this basic understanding, we will rearrange these terms, rearrange them and get in terms of x. That means, okay, it is in terms of y. Get x is equal to, okay, what I mean over here is, get x is equal to everything else. So x is equal to what? How do we do this? Take square root on both the sides. That time x is equal to root of y. Here, just change this x to the other side and bring y to the other side. There will be 2 minus y. Now, you need to find the point of intersection. Where does this meet? You can find the point of intersection by just equating these both equations. Instead of x, just equate these both. That is root y equals 2 minus y. Now, when you solve these, you will get the answer. Now, how would you solve? You should solve it as a quadratic, isn't it? Now, when you solve it as a quadratic, what happens? You can't solve it directly now because square root, it's very complicated. How do you do it? It's sorry, not quadratic. You need to remove the square root. That's what I meant over here. How do you remove the square root? Is squaring on both the sides. Square on both the sides. That will be y equals 2 minus y the whole square. Now, when you have y equals 2 minus y the whole square, how do you simplify this? It is 2, I'll just write over here, a minus b the whole square. That is a square minus 2ab plus b square. I hope you remember this identity. You must remember this identity. It is a minus b the whole square identity. Now, directly solve this up. It'll be 2 square, that is 4. I'll directly write it over here. 2 square is 4. A value is 2 and b value is y. So 2 square is 4 minus 2 times AB. 2 into y into 2 because this 2 is extra, right? 2 times 2 is 4 and y plus y square. Now all you need to do is, this is it. Now you need to just rearrange and get the terms. I'll just show over here. So you have 4 minus 4y plus y square. Now get this y to the other side. Get all the terms to one side and one side must be equal to 0. So this is it. You're equating everything to 0. Why do we do this? Because now we can easily solve it in calculator using more, 5 and 3. And now what you can do is put the coefficients 1, minus 5, and then we have 4 and solve. We are getting 4 and 1. Now let's keep both those values in our minds. So 4 and 1, right? So what is the initial value given over here? It's 0. So we know one of the limit is 0 on the y-axis because we're dealing with the y-axis. In the formula, we know it will start from 0 over here or over here. But what are the values? We got 1 and 4. So 1 is the nearest one. So first intersection point is at 1. So we will take 0 and 1. If it was -1, -4, we would have taken -1 to 0. Okay, always the lower value to upper value. But the problems will be accordingly given. We don't take 4 because 4 is another meeting point, but we have got this, we need just this area already. Okay, so we take 0 and 1. And therefore 4 is beyond the limit, we ignore it. Now last one is to substitute it in the formula and solve. This was the formula we saw, integral CD f of y minus g of y dy. All you do is, what is the right function? Right is 2 minus y minus square root y dy from 0 to 1. Put it in the calculator. It is very straightforward. Use this symbol over here, integral, definite integral. And then you just use the brackets. 2 minus, there is no y value, so use x minus, square root alpha x. Just remember that is that though it's x, we are just using that as a variable. Okay, and then limits are from 0 to 1, and here you get the answer. Take a while. It's 0.8333 units square because it's the area. That's it. So that is the answer. That's how we solve it. Very straightforward. Please make sure you solve by using the same method, then all are solvable. And all the methods are over here. See, it is same like what we had done, but over here there is no square. Okay, we had square over here, and then everything is same. So you can see here what will happen. 2 minus y minus y. Why? Because there is no square. The other one we had square over here. That was the difference. The answer is 2. So for few of the problems, you can easily use basic geometric formula and compare the area. Now this is not possible all the cases. Now over here, no, it's not possible. We can't use geometric formula. Over here, it's not possible. But over here, look at this. With the basic graphing, you know this is a y is equal to x is straight, then minus 2x is like this, 0. What is the intersection? Over here, it is 0 and 2. Then we can use the triangle formula. Half base into height. Base is 2 and height is 1. We get that in the intersecting points. 2, 2, the answer is 1. You can just compare this. But you know, obviously, if you do one method, it's enough. And this is an MCQ, so only this much is enough. This is extra method. But if you just follow whatever I showed it over here by steps, you can solve all this. Please follow all the steps. You will definitely be able to follow this. Only the values have been changed over here. And over here, this is a trapezoid. Trapezoid means if you have a triangle, if you remove the top part, the remaining part is a trapezoid. You can use this formula over here and solve it. Similarly, you can compare it. It'll be the same. So these are the answers over here. You can quickly go through them. Just the method which I just told you, and then you can easily solve. And please go back to the first topic and second topic as well, because we had solved them. See, some of they were similar. Now, some of only the differences over here along the y-axis, the right and minus the left function. In the first topics, we did upper minus lower function. Some of the functions are given directly as x is equal to y and everything. It's very easy to solve them, and sometimes you need to change them and then solve. All the methods are, all the problems are solved, and the graphing is also given. So please solve it by yourself and then look for the answers. That's it. The 12th topic is again find the area between two curves using definite integrations. Let's just recall the formulas and we will directly solve this, not by any formula or anything, but just the main understanding of this is essential. Now, for example, when you have two functions, the formula is given like this: the upper function minus the lower function. Now, x-axis is between them, so we are solving with respect to x, f of x, okay, with respect to x. And now what happens is, this upper function minus the lower function, because this upper function means all the values below this is included, minus the lower function means all the values this is excluded. Now these will be excluded, only the shaded region will be considered. So it is always the upper function f of x minus the lower function g of x, and the limits are a to b. Similarly, we saw just in the previous video this particular formula where we find the area between the curves, and now with respect to y-axis, it will be the right function minus the left function. These are the basic things. Now, the next one over here, this type of problem, you don't need to solve all that just like what we have done in the previous video or before that. You don't need to do all that. But here, this is very crucial. For example, understanding the concept. That is it. Now, let's look at this figure. The figure is given. In terms of A1, A2, A3, identify the area given by each integral. They have given you definite integrals. Now, the obvious thing would be just solve it up, right? Okay, let's use our calculator and try solving it using definite integral. 2 alpha x minus x squared, and the limits are from 0 to 2. Okay, so it's 4 by 3. But do you think anyway the 4 by 3 is there? No, they want you in terms of, a1, or say like this. Let me just show you in terms of a2 or a1 plus a2. That is what they want. How would you understand this? 4 by 3 is 1.33. Now, one way is, you have to find the area of the entire thing and then find the area of each things, and then you will get it. But the easiest way would be, look at the functions which are in consideration. 2x, this is the figure. Where is 2x? 2x is this, right? Okay, what about the next function, x squared? Which is the next function? It is this. So you can see, if you draw a straight line, upper function minus the lower function, upper function minus the lower function along this axis, x-axis, and it starts from 0 to 2. So which is the area in between from 0 to 2? This area, whichever I put brown color shading, is the region. Okay, that is very bad shading, but you get it. So that is A2, area 2. So this answer is basically A2, that's it. So now you can see over here the same thing. Area 2 is the answer. Now let's see the next one. What about this? 4 minus x squared. Now let us see 4. Where is 4? We know x squared is over here. Okay, that is fine. Then where is 4? This is the thing. Again, from 0 to 2, it's x-axis, but the upper function minus the lower function. Upper function is 4 minus the lower function. So which are the regions in between this from here to here? All the regions in between this. You can see that is A1 and A2. So sum of them, A1 plus A2, that would be the answer. That's how we do it. Now, same way we can solve all the others, but right now, pause the video and try solving it by yourself. Just go through this. Pause it over here, solve it, do all the answers, and then we will look into the answers together. So that is it. Now we will see over here. I hope you have paused and tried. Now this A1, A2, A3 total is the, over here it's a triangle. Sorry, my bad. It's a rectangle. It looks like a square, but since the dimension 4 and 2, it's a rectangle. Now let's see, but we do not need to know whether it's a rectangle, square, it doesn't matter. We just need to denote it by areas. Over here, 0 to 4, when you look at this limit, you must understand we are dealing with the y-axis. Now, so 2, where is 2 over here? 2 is this line, and then root y, square root of y. Look carefully, you have x, y equals x squared. Take the root on both the sides. What's going to happen? It's going to be x equals root y. So that means this function and this function is what we are considering. The right function minus the left. Right side is 2 minus the left side will give you this region of area, isn't it? So the answer is A3 for this. Right minus left along the y-axis. So it is A3. Now, this is for you guys. Try it now. Pause the video and try it. I hope you tried it. Again, it's the same thing. Blue one is root y, because you can take the square root on both the sides. This is going to be square root y. This is the blue function. And then we have y by 2. This is solved. Take y to the other side. X equals y by 2. So that means this one. And it is along y-axis 0 to 4, isn't it? So it will be right side minus the left side, which is in consideration. A2 is the answer, A2. So this is it. That is how we can solve it. Just by looking at this, you can easily solve it. Choose the correct option. Now, similarly, you can do these as well. Over here, A2 plus A3 is there. You need to write in terms of equation. We just now saw that. Now, you have A2 and A3. This, sorry, now it's very, very tricky. Okay, anyways, this one and this one, okay? 2, this is the first function, right function. 2, sorry, A2 and A3, before we see the answers, only this region we need, okay? This region. So now you can do one thing. The right side, right function minus the left function is the easier one. Don't go with the x-axis because it'll be this minus this and then you can do it. It's up to you, it's fine. But it's much easier like this. Right side, that is 2, radius is 2, minus A2, A3, this function. What is that? That is given by not 2x. You must write in terms of y, because y, it's a right minus left y-axis integral from 0 to 4. 2 minus, take the 2 to the other side, will be y divided by 2. Now, just now we solved, over here we told A1, A2, A3, so on. Now here they have given A1, A2, you must write the equation. Same like that. Now if it is A1 plus A2, similarly you can do the same thing over here. Now we have just now solved over here, remember? See? Where did we do that? A1 and A2, it's over here, A1 plus A2. So this is the thing. Now why A1 and A2 is the A1, A2. Upper function minus the lower function. You must remember when to use upper function and lower function, right and left. If you're getting confused, please go to the previous video. It has been explained in the 11th topic clearly. So that concept is used over here. Same way you can see this by yourself and then solve it. Because we just now did these. Now it's the other way around. So that is it for this topic. Please be careful with the formulas. Just remember the limits. Now, whenever you're dealing with the x-axis limit, that means it's upper and lower, upper function minus lower function. When you're dealing with y, it's a right side minus the left side. So that's the main concept. The 13th topic is on the surface area, where we need to find the surface area for solid. Now using definite integration. This is a very simple one, provided we use a simple formula. Now, for example, if you want to find the surface area of this, all you need to know is this formula. Now, this is already derived. You have to just substitute this and solve it. So you do not need to, break your head on the derivation or anything for now. I'll just explain you what this formula means. If you recall, the surface length was similar to this, but only thing is this 2 pi is added. In surface area, this is added because it's a circle, right? So we add the 2 pi. And now, other than that, this is square root 1 plus f dash of x the whole square. This is important because you need to find the derivative of the given function. And then this is the function as it is. I'm sorry, this is the extra term, I believe. 2 pi f of x. Whereas this would be the surface length. And this is it's like 2 pi r. The circumference is added basically. Now the integral from a to b, the limits will be given. We will look into a problem. So this is a problem. Find the surface area generated by revolving this particular equation. X to the power 4 for x is greater than 0 but less than or equal to 1. It's greater than or equal to 0, less than or equal to 1 about the x-axis. Now all you need to do is first differentiate this, because in the formula we need the differentiation, isn't it? So differentiate this. X equals x to the power 4. This 4 comes down, you'll get 4x to the power 3. That is the differentiation. That is f dash of x or y dash. The limits are given 0 to 1. Use the formula and simply solve it directly. Use the formula 2 pi f of x. What is the function? Function is x to the power 4. Then square root 1 plus f dash is 4x to the power 3, the whole square. That's it. Now all you need to do is put it in the calculator and solve. Your answer would be 3.44. We can just do it over here. Use the integral. Now 2 pi is by shift and this symbol over here, into the function that is alpha x to the power 4 multiplied with square root 1 plus, now it's better to use the brackets because there are two terms, 4 alpha x cube, close the bracket and square it up. That's it. And now the limit is from 0 and it goes until 1. This is your answer. Now, if you're thinking, why didn't I use radians? There is pi or anything. No, we don't use radian. Pi, it doesn't matter. Only when the theta or angle comes, we have to change to radian. Because the angle, radians, it's basically 2 pi, will in degrees is 360 degree. If you don't change the mode, it will consider to be 360 degree. Whereas generally it will be given in pi. We have to solve in pi radians. That would mean pi is 180 degree, right? So that's why. But anyways, just forget that. The best way and the easy way to remember it is, if you got cos theta, angles, tan theta, sine theta, then you need to use the radian mode. Okay. It doesn't matter if you don't use, but generally otherwise it's in degree mode. So now this is the degree. It's 3.44 because 6, this increases by 1. Same way you can solve these. Only remember, you need to derive this and then apply the formula and use the, just over here, just substitution. That's it. Same way you can do it. Now, please try all these by yourself and then check the answers, please. Now here, all these problems are same way. It's only with the x-axis revolution and the limits are always given. And over here you have the function. If it is sine, remember you need to derive sine. It will be cos x. And please change to radian mode and solve. All the derivations are over here. You can look into it. The formula is not there, but the formula was mentioned over here. This is the formula. So please write that, by heart that formula. You should know the formula, otherwise you cannot solve it. So once you know the formula, substitute, solve, and then check the answers. Please don't get confused over here. The limit, it's from -2 to 0, because lower number, the smaller number is -2, negative numbers are smaller, 0 is greater than -2. That's why. So all these are shown over here. Please do solve them by yourself and then check for the answers. The 14th topic is among the easiest of all in part 2. And only thing is, you need to find the initial position and initial velocity. We'll directly look into the problems. These are the questions. If you have all, I'm sure by now you have known this concept already. So it's better you just try to do them by yourself. Please pause the video now and try to go through them at least. Now we will look to the how to solve them. Over here, the first one, an object is dropped from a height of 80 feet. What does that mean? It is being dropped from a height. Okay, the position we know, it's from here somewhere. 80 feet is the initial position. This is 80. Okay, do we know the velocity? Is it mentioned? No, nothing else. Only position, initial position. So why not? That is the initial position is 80 feet, whereas the velocity is unknown. So we just write it as 0. An object is dropped from a height of 100 feet. It's the same thing. See, now over here, let's just quickly see. These two are the same. Only over here, when you see the feet per second, there is velocity. So it's just y of 0. That's it. Y of 0 is 100 feet, and that's it. Nothing else. Whereas now an object is released from a height of 60 feet with an upward velocity of 10 feet per second. Initial position is given, y naught of 0 is 60. But this upward velocity is initial velocity, that is y dash of 0 of 10 feet per second. It's positive because it's upward. Now over here, similar to the previous problem, we have downward velocity. The height is 20 feet. Instead of 60, we are 20 over here. Now, what about this downward velocity of 4 feet per second? Y dash of 0 is 4 feet per second, but the sign is negative. That's the only thing. And this is it. That's why it's one of the simplest and the easiest among all of part 1. Now we move on to the topic of projectiles. Before I begin, I want to quickly remind you, you can see a link to the video on projectiles in the description. Please do check that video out. It is over an hour, but it is in detailed explanation on the topic of projectiles. The information might be useful to understand thoroughly to solve any type of problem. Now we will look into a couple of problems. Here we have, if a diving board is 4.5 meters above the surface of water and a diver starts with initial velocity of 2.4 meter per second in the upward direction, because it's positive then. What is the diver's velocity at impact assuming no air resistance? This is very crucial. What is exactly impact? Now, he's already above 4.5 meters. This is the, say, the surface of the water. The impact would be when he comes and hits, the diving board comes and hits the surface. Impact. So the initial height over here is 4.5. See, this is the initial height. When the height is 0, that is called the impact height. The height of any time when it's 0, it's impact height. So now we directly can't find this. It's a long method. Now we'll see how it is. First, we don't have any equations over here, right? What do we know in general in real world? We know the acceleration due to gravity. But before that, let's write the given. We know h of 0, that is initial velocity, is 4.5. And the initial, sorry, I'm wrong, sorry. Over here, it's initial position. Okay, it's very easy to get confused over here. Now, whenever you have a distance, that's the position, only distance. Meter per second is the velocity. The initial position is given as 4.5 meter and initial velocity is 2.4 meter per second. Next, you need to understand what needs to be solved. That is h dash of t, but at t is impact time. Okay. Now we know the acceleration due to gravity is negative 9.8 meter per second square. All you need to know, all you need to do is integrate this, and then you will get the velocity. Integration of acceleration gives you velocity, whereas integration of velocity gives you the position. Position can be written as s, or anyway, if you understand it's enough. Whereas in the previous term, we had derived it. If we derive position, we get velocity. Derivation of velocity is acceleration. But now it's other way around. We are coming backwards. Now, so we found the velocity, but this velocity is general velocity at any time t. How do we find, now when you integrate it, you will have a constant of acceleration, that is c. How do you find the c? You know the initial velocity at h dash of 0 is 2.4. So instead of time t, substitute 0. All you do is h dash of 0 now. We know that value is 2.4. So substitute over here wherever t is there as 0 and substitute this 2.4 meter per second in this case. H dash of 0 is 2.4. Right side, this becomes 0. What is remaining? C. So basically C is your, C value is the initial velocity. There is also another easy method where if you see anytime initial velocity or initial height is given, directly take that as the constant of acceleration. Sorry, constant of integration, C value. Why? Because it does not change, all the terms become 0. Only when there is trigonometric function, you cannot do that. Or some rare cases, you cannot do that. But in general, if you have a polynomial equation, you can just take this as C. Now, I hope you're clear until over here. We just took the acceleration. We know it's a constant value, integrated it, found the velocity. And to find the c, we substitute h dash of 0 and find the c value is 2.4. Now we can write h dash of t is minus 9.8 t plus 2.4. Okay, we found the velocity. But is this the velocity which we want? No, we need the impact velocity. How do we find the impact? We need to derive this again, find the position now first, because then we can find the impact time. Let us integrate this, not derive, I told derive, sorry, integrate this and you will get this as the answer. Now, whatever integration of velocity, whatever you get is the position. Now, this is useful. Why? Because we know the, wait, first of all, substitute this c as to 4.5 directly, or you can substitute this zeros and do it. Now we got the position. Now over here, we know that the height, the impact height must be 0. Impact means it's touching the surface, it's touching the initial base. That must be 0. So you must understand this. This is the surface of water. There's a diver who is above 4.5 meter. Impact means it's touching the surface over here. So the initial height is 4.5, but the impact height will always be 0. So h of t must be 0. Now you can solve this as a quadratic equation. All you need to do is put in the calculator and solve. If you have not, if you do not remember this, just remember, take out your calculator, press mod phi 3. This is how you solve quadratic equations. Now over here, you need to just put in the coefficients 4.9, and then this is before x squared. Over here, x is not, it's t squared, it's fine. Then we have 2.4, and lastly we have 4.5, and the equations of the values are over here. Now it is minus 4.9 plus, okay, so these are the answers. It's 1.2 and 0.7, but negative. Now over here, look carefully, we are getting two values. One is positive, that is 1.23, and one more is 0.74. You cannot take a negative value because we are considering this t as time, right? We are dealing with time, the position with respect to time t. Impact time cannot be negative. So just disregard this negative value, just take the positive value 1.23, and that will be a time. Now what it means is, from the beginning, when this diver jumps, the time it takes for this diver from 4.5 meter to reach the surface of the water is 1.23 seconds. Now if you substitute this time, that 1.2 seconds, in this velocity equation, you're going to get impact velocity, because impact means touching the surface, and we can model the time, that is 1.23 seconds is the impact time. Now the velocity, when solving the equation of velocity at this impact time, we get the impact velocity. That is, just put over here instead of t as 1.2 and solve it, you will get the answer. This is the impact velocity. So that's how we solve it. Now let's see one more problem. Now it's similar. You need to solve it by yourselves. Solve more and more problems. You'll be thorough with this. Over here there is an object which is launched at an angle pi by 6 from the horizontal with initial speed v0 equals 98 meter per second. We need to determine the flight and the range of projectile. Just like the previous problem, let's write the given. The angle is given and initial velocity, initial speed is given. That is the velocity. Now sketch a graph to understand better. Now there's one thing over here. There is an angle, so we need to have two different orientation. That's the velocity in the vertical and horizontal, because there's an inclination for the launch. Now over here we get v0 sine theta for the vertical side and v0 cos theta for the horizontal side, and this over here is what is the projection of that, whatever is thrown. So now to solve, we need the time of flight. That means now this object is launched from here, right? How much time will it take when it reaches over here, when it reaches the ground? And then this distance that is covered by the object. Those are the two things we need to solve. But here now it's same like the previous one. Please be thorough with the previous problem, or you can just click on the description and watch that projectiles lesson. There are many real world problems. If you're thorough with it, this will be very, very easy. Use the acceleration. Now we will deal with the vertical component first. Acceleration in the vertical is always gravity acting downwards minus 9.8 meter per second square. Now we can find the velocity easily by integrating this, nothing much. And then we got this in terms of c. What is the c value? You need to find it. Now here you can't directly assume any value. You need to solve by finding this y dash of 0. What does y dash of 0 means? Y dash of 0 means over here the vertical component, initial velocity along the vertical component, because we have theta and the initial velocity given, right? So we need to solve for it. Y dash of 0 is 98 into sine pi by 6. You need to solve that. You will get 49 meter per second. That would be the c value. Sorry, let me just go back. Okay. See, now one quick thing. When you're solving this, use shift mode and 4 radians, and now type in the value 98 into sine of pi by divided by 6, close the bracket. That is the answer, 49. So then what you do is you just substitute this 49 in that C. We got the velocity. Now we can find the position by integrating this. Just easily find it out. Now over here, the altitude is not mentioned. It's 0 from the base. So altitude is 0. So this is not there. This is basically the initial position. That is with regards to the vertical. Now, how do we find the time of flight? Basically, we know if you throw anything, throw an object, it'll start from 0 and it lands when the uh, height is 0. So basically, if you equate this as 0, the height as 0, you will find the starting and the ending time. So let us just solve this as mod phi 3, that is negative 4.9, and then we have 49. Now, this last one is 0. Now, let me just solve this. We have got 10 and 0. What does it mean? Now, try to understand over here. We have got this position function. Okay. Now, when the time, when the height is 0, either you will be throwing the object upwards or it lands on the ground. Those are the only two possibilities. Why is it so? Why? Because when you throw, it is starting. So the time is 0. See, time is 0, t is 0, t value is 0 when you start. And when is the t value ending? When it finishes, when it falls down. So you get two values of t, that is 10 and 0. So when we substitute this y of t as 0 and solve it, we got t equals 10 and 0. Now 0 is the launch time basically, and the landing time is 10 seconds. Now basically landing time is the time of flight. That much minutes it was on flight. Now we have to just quickly solve the horizontal component. Horizontal component is not same as the vertical component, because if we go back, we can see, okay, v sine theta is the horizontal component, vertical component, whereas the horizontal component is v cos theta. Now here what you need to do is understand that the acceleration due to gravity is only for the vertical. Acceleration on the horizontal component is not mentioned, so basically it's 0. The projectile is has only gravity acting on it. They have not mentioned any other acceleration, so it's basically 0. And then we start solving the velocity. The velocity over here would be integral of this. Basically it's again 0 and plus c, because we have only the constant of acceleration. What is that c value? You can easily find it by this formula: x dash of 0 is equal to v naught cos theta, and then you get that 98 cos theta. Over here you can use the calculator and solve it. We just now did this over here. Use radian mode. Please make sure you're using radian mode, and then you can write 49 root 3, and that, sorry, I'm mistaken, 98 into cos pi divided by 6. So this is it. Now over here you get 49 root 3. Now this one, 49 root 3, is basically the velocity, the horizontal velocity. Now to find the position, integrate this, you will get the answer. There is no, the c value is 0. Now all you need to do is add this time of flight over here. So this is the horizontal velocity, right? If you multiply it by the time, you basically will get the exact horizontal distance. So multiply it by 10, this is your horizontal distance. That is how we solve this. Same concept is used. You need to solve all these by yourselves. The explanations are over here. You can pause it and check it out. Please do solve it by yourself and then check for the answers. If you're getting any doubts, please click on the video link in the description that has explained entire projectiles lesson. So all this, you can just pause it and check the answers later on. So this is all this. That's it. Now we move on to the 16th topic, But before I start, I want to remind you that 16th topic is just the same as the 6th and the 7th topic. It's literally the same page number, question numbers, and the topic as well. It is just on integration. So I would highly recommend you to watch the previous topics, that is 6 and 7. I will also add the link to the video in the description for the videos 6 and 7. So you can, if you're all new to this particular video, pause over here, go back to those two videos, watch them, and then watch this. So over here, we need to recall the basic integration formula because it's about integrals. So this is the power rule. Then we have 1 by x, that is natural logarithm x plus c, sine, the trigonometric formulas. Please pause the video. You need to revise it, recall them. You need to memorize these formulas for integration. Again, I will repeat one thing. Whenever the answer is cos, you will have a negative sign. Wherever there is c, that is cosine or cotangent or cosecant, you will have negative. Similarly, there are more formulas on integrals of exponential functions. So these are the exponential function, tan, inverse formulas. Please go through them. You need to remember these. So then we will solve this type of problem over here, because the previous types, now one second, I will show you the 8 questions. These are the 8 questions. These are the 8 questions. We have dealt with all of these. So let me just go in detail with the last 2 type. Over here, we have to integrate x square minus 5 the whole square dx. The actual method would be to solve this identity first. This is in terms of a minus b the whole square, that is equal to a square minus 2ab plus b square. So use this identity and solve. But here instead of a we have x squared and instead of b we have 5. So a squared will become x squared the whole square. Please note, because the a value is itself x squared, we get double square, x squared the whole square. And then all you need to do is minus 2a is x squared, b is 5 plus 5 squared. That's it. Now simplify this. Always remember, when you square the powers, now if it is x power 2, sorry for that. Okay, let me just, okay, if it is x power 2 multiplied by x power 3, what is going to happen? You're going to add the powers. It's going to be 2 plus 3. It's going to be 5 over here. But if it is x squared the whole power 3, then you will have to multiply the powers. It will be x to the power 6. Okay. Here it is 2 power 2. So even if you add and multiply, it's going to be the same answer. But you need to remember this. In case you get 3 over here, then remember, when it is x squared the whole power 3, when you're powering already a power term, it'll be multiplication. In this case, it is addition if you're just multiplying the terms altogether with the squares or powers. Now then, this is the simplified form. 5 times 2 is 10, x squared, and 5 squared is 25. Integrate the above because now it's also simplified, right? Just integrate it. So x to the power 4 will be 5 by 5 minus 10 squared will be 10 cubed by 3, minus sign remains, and 25 will be just x plus the constant of integration. That is the answer. I have done the shortcut to the integrations, so you can directly do this in the calculator. 16th topic, you will have 4 options, so you can use the calculator method as well. If you do not know the calculator method, please click down below in the description. I will put this as well, the shortcut to the shortcut method to do integration. Any integral problem, even if there is a variable, you can do it in calculator. So please watch that as well and then try these by yourselves. So if you're finding this hard, watch the video number 6, watch the video number 7 and this previous one, and also the shortcut method to integration using scientific calculator. You will definitely find the answers. They're very simple, but if you want to solve them each one by one, here is the steps. You can see them. They're very, very simple. The same thing what we had done before. You will have to use U substitution at times. Now these are the methods. You can pause it and go through it, or you can go to the previous videos. So these are the steps over here. So last one, just now we did it. You need to use this. Now over here, expand this x square and then multiply the x. That's it. That's the only difference. And you will get the answers. So in the next video, we will do topic number 17. The 17th topic is again on integration, but this time we are using integration by parts. There are some integral problems which cannot be solved in regular formulas. So there is a formula which we can use. It is not the product of integration, but there are two terms which cannot be solved at all. We'll take them as u and dv, and we part them into separate parts, and then we solve them up. So this is the formula which you must remember, integration by parts. Now this is asked in the part 2, 17th topic. We can use the direct method, the shortcut method of integration as well. That is up to you. But now we will go through integration by parts using the formula. It is integral u into dv equals uv minus integral of v du. See over here, there is no v term. We just take u and dv. We have to integrate this dv to get v. And sorry, there is no v term over here. There is u and dv. There is no du. We need to derive this to get du. We will look into this. It's very simple. Now you have x into sine x. There is no way you can solve this because it's not plus, it's not division, it's not possible. We do not know any formula that can solve this. So we have to use integration by parts. Now very important is choosing u and v. Look, u needs to be a term that is easy to differentiate, whereas dv is the term easy to integrate. Now look over here. Sin x. It doesn't matter integration or differentiation. It's almost the same to do it. Okay, so leave that. Look at x. Is it easy to differentiate this or integrate it? Or is it like a complicated term after integration or differentiation? Let's look. X, if you differentiate it, it is 1. It's so simple. Whereas you integrate x, it'll be x squared divided by 2. This is going to be much complicated, right? So we choose u, which is easy to differentiate, that is x. Because this is so hard if you differentiate it, right? So take the other term for differentiation. Now remember, not only sin x, you need to also take dx whenever we choose it as dv. Now differentiate du by dx. What is going to happen? Derive the u terms and dv terms. What it means is you need to differentiate du by dx with respect to x. You will get 1. So then what is du value? Take this x to the other side. Du is equal to dx. Now integrate this side over here. What do you get? Integration dv, integration of sine x will be minus cos x. Sin x dx is minus cos x. So v is the left side. Integral of dv would be v. So now you have got du equals dx, v is equal to cos x. And now use the formula of integration. Integral u dv, that is, we have chosen u as x and dv as sine x. We can substitute over here. So in the question, basically, u dv is the question itself, equals u. What is the u value? X. What is the v value? Negative cos x minus integral of v. What is the v value? Minus cos x again. Du is dx. Now it's possible to solve because, here you can simplify. X times minus cos x will be minus x cos x, and integral of minus cos is positive. Integral of cos is sine. This minus will just remain over here. So, and this 2 minus minus becomes plus. And don't forget the constant of integration, that is c. This is how you solve this problem. That's it. That's the answer. Now, since these problems are in the topic 17, you can use the shortcut method for integration. The video is down in the description for the shortcut of integration. Please do check it out because you can solve any problems using your scientific calculator. But if you're so willing to know how to do this in calculator, I'll quickly tell you. So you need your scientific calculator. Since we are dealing with trigonometry, shift the mode to radians. That is by pressing shift, mode and 4. And now you just have to put any random x value for this. Say I'll put 1.5, 0.5, okay, for x. multiply it with sine 0.5 itself. It should be the same value for x. And what is the answer? Solve it. It is 0.2397, and it goes on. Now we know that derivative of any answer. Now for example, I'll just give an example. It's better to write it and show it. Now you have x. Say you have x to the power 2. Derive this. What is the derivation of this? It'll be 2x. Now if I have 2x, what do I do? Integrate. This is d by dx derivative. Now integrate. I'm going to get 2x squared divided by 2, which cancels with this, and you're getting x squared. So there is a relationship over here. When I derive x squared, I'm getting 2x, but when I integrate this 2x, I'm going to get the derivation back, isn't it? So now if I integrate this, I will get this answer. So now if I derive this, I should get this answer, same one. So that is why what I did over here, basically this integral is having a constant. The answer will have a constant of integration, but this will become 0 because derivative of this is 0. So that's why we use the x value in this given question. Instead of integrating, use that x value. We solve the answer. Right now you will have 4 options because it's MCQs. So select one of the option. Select one of the option and just press shift and dy by dx. Type the one of the answer as it is in terms of x itself. Okay, cos x, close the bracket, plus sine x. And then don't write plus c because any constant, it's the same thing, it'll be 0. The x value should be taken as 0.5 because we had assumed 0.5 and solved this. Now look over here, the answer is exactly the same. Only one option among all the 4 will give you exactly same answer, and that will be your correct answer. So if you forget this formula, if you got confused or stuck, then do this and check. So among the 4 options, this would give me the correct same matching answer. Whereas if I had anything else, say over here it was sine, I will not get the same answer. It is only possible for one correct answer. So that's how you can even try it for year. Do it by yourself. You can check the video down in the description later on. Now over here as well, take U and dV. Very important. Now you don't have integration for ln x, that is len or ln or natural logarithm. So you just take it u is equal to natural logarithm x, and what is dv? What is remaining? That is dx term. And now what we will do is we'll integrate this. It becomes 1 by x. Integration of dv and dx will be x over here. V is x. Now just do the substitution in this formula. That is ln x dx equals u is natural logarithm x, v is x, minus integral v is again x, du is 1 by x dx. Now simplify this, you will get the answer. Over here, integral of 1, that is x, plus c. That's it. If you're getting confused, do the formula, do the shortcut method and check your answers. Please do try this. All the answers are mentioned over here in the all have been worked out. You can check all the answers, and you can even try the shortcut method over here and you will get the same answer. So you can check the answers in detail. Let me just show it. Okay, you can just pause it. Also, you can find this presentation if you click on the description. There is a link where you can download the presentation. Now these are direct integrals. Definite integrals are very simple. All you need to do is put this as it is in calculator and you will get the answer. But the only difference is, let me do this. Sorry, let me do this problem. Now here in this case, if you just type this, it's going to be all right. That is 2x cos x, and you need to press 0 and pi. You will get the answer -4. But what about this side? Let's do the same problem over here. It was sine 2x. So I will have to just remove that. Cos to sine. And then there was no 2 over here. Let me just change that to 1. And now the answer is 0.435. Why? Because always you will get the simplified answer in decimal symbol, okay, like this. So what you need to do is all the four options need to be solved. So you need to solve the all the four option. Only one will be the correct answer. That is half cos 2 plus 1/4 sine 2 bracket sine close the bracket, and this will be the correct answer. Why? Because when you simplify this, you're getting the same answer what we got in the calculator. Only one will be the correct answer that will match, so that's how we can easily solve it. Please do try these problems by yourselves and then check the answers. You can pause the video to check the answers if you want. So this is the 20-second, or directly try the calculator methods. It's very straightforward as well. All these are the answers. All have been worked out. And that's the end of this topic. So this was the integration by parts using the formula, or you can do it by calculator, or if it's definite integral, it's very straightforward. The next, so please stay tuned for the next video. We will deal with the topic number 18. The next topic is the topic number 18, and here again we are dealing with integration, but this time regarding the trigonometric functions. Now, again, I will recall you trigonometric or any integration for that matter. If you have the MCQs, if you have options, can be solved in the calculator. So it is highly recommended to use that method over here, because if you're getting too much confused or if you have too many formulas to remember, then you can just use that for now. Part A and part B, you can use the calculator method. If you want to know about the calculator method again, you can watch the previous videos, or you can watch the shortcut method to integration down in the description. Please click on that and watch it. Now we will see this as well. These are the Pythagorean identities, trigonometric identities. You must remember all these. There are plenty of these formulas in the previous videos. In the video number 8, I believe, or somewhere over there. In the part 1, this was already explained. So this is kind of, refreshing it again. These are the double angle identities. Pythagoras identity are very crucial if you're solving it directly. Then here, these are the integrals for Pythagoras for trigonometries. So you must remember these. Now over here, again, I'll just quickly recall whenever you have cosine, cotangent, or cosecant as the answer, it'll be minus. See, even over here. Now these are the two extra formulas. Now otherwise, if there is no cosine or there is no c, then it becomes it's just positive. So that is the thing. Now then, we will quickly dive into this problem. Over here we have got evaluate cos to the power 4x sine cube x dx. There is no direct substitution. There is no formula you need to do use substitution. You need to choose the appropriate value for you. Now you can see there are two functions. Now sine is less and this is more, so it's better to take not as a even number. It's over here we would take cos 4 because it's higher power, and then we can easily dissolve this other term. So it depends, it's not just even, or it's not really higher power. It depends on different situations. Sometimes you don't take sine at all or cos at all, you take other things. So this u value would vary depending on the question and the situation. So as you practice more problem, you will get a hang of it. Now over here, u is taken as cos. You don't take the power, you just take this. And then what happens? Du by dx is minus sine. What you do is you derive this. Remember, derivation of any c values like cosine, cotangent, everything is negative. You add this negative sign over here. So this is it. Now what do? We need to get dx, right? So swap this, swap this with dx. So it'll go to the other side, it'll become minus du by sine x equals dx. Now then, we will just rearrange and write these terms. Instead of cos 4x, cos to the power 4x, you write u to the power 4, and then sine cube. Okay, now one more thing. Before we do the substitution, right, we have to rearrange these terms. Why? Because now this was odd, right? Sign was odd. So one of the sign will go. But what about this power 2? This, if we have sine squared, we can use Pythagorean identity and get everything in terms of cos. That's what we do now. See over here, cos to the power 4. Sine squared is 1 minus cos squared x. Because we know from Pythagorean identity, cos squared x plus sine squared x equals 1. So if this is the case, just take cos to the other side. It becomes sine square x equals 1 minus, or subtract both the sides by cos. It'll be minus cos square x. So that is what happened over here with the sine square x. And now this sine square x, leave it as it is. Now substitute the u values, apply the u's. So we, instead of cos to the power 4x, it'll be u to the power 4, 1 minus u squared, because cos squared x is u squared. Sin x, leave it, dx will be minus du by sin x. Now these both cancels, negative sign remains, u to the power 4, 1 minus u squared du. Multiply this inside. What is going to happen? U to the power 4 into 1 is u to the power 4. U to the power 4 into u to the power 2. And remember, when you multiply terms, like terms with different powers, you add the powers. You just add the powers. Okay? Only when it is squared. Imagine you're squaring this, then you multiply the powers. It will be u power 8. But now you're multiplying, so it is powers are added. It will be u power 6 du. And now you can easily integrate, isn't it? U to the power 5 divided by 5 minus u to the power 7 divided by 7 plus c. And here, this is the, now multiply the minus sign inside, and here you get it. So now it's not over. You need to substitute the whatever you had considered back into the question, and here you go. That is your final answer. So this is constant of integration. Now, I will quickly do the shortcut method as well, because that is very handy in such cases, because sometimes you might get stuck anywhere. So, oh, you got the correct answer, well and good, but double check your answer by the calculator method. Now, in this case, all you need to do is first shift mode and radians, and then you need to type it. Cos, take any x value. For trigonometry, I generally take 0.5. I don't take huge values. Don't take 0 or 1. They are tricky values, because sometimes it will be 0, right? So it's a problem. Now, what do you do? Cos x. This 4, if it is for cos power 4, it must be the whole 4, like this. After this x value, you can put the power. Always remember, if it is cos to the power 4x, that is equivalent to cos x the whole power 4. You can put brackets as well. It's the same thing. Only when it is cos x power 2, this is only for this. So it will be, I should have squared inside. It will be 0.5 squared. But now it is since cos, it will be entire squared. I'll just put the brackets anyways. Even if you don't put the brackets, you will get the correct answer. But if you should power it accordingly, correctly, multiplied with sine x is 0.5, close the bracket and make it cube. And now I didn't close the bracket. Now it's proper. That's it. Press equal to, your answer is 0.06536. Okay, the x value was 0.5. Now all you need to do is put this term in derivative, definite derivative, dy by dx. So minus cos over here will be cos x is 0, sorry, don't put 0.5 over here. You need to put, instead of x equals that blank, you should put 0.5 over here. You need to have it as x itself. Please remember that. To the power 5 divided by 5. I'm not putting the brackets because it'll be very clumsy over here. That's the reason. Or you can put the brackets. It's the same thing. Cos x, that is alpha and x, close the bracket, to the power 7 divided by 7, and plus c. C is any constant. You can write anything or you can leave it blank. It's the same thing. I'm just writing to show you that it does not make a difference. 0.5. The answer is the same thing, whatever we got. Now I'll just remove this 423. I will get the same answer. Why? Because whenever you do dy by dx of any constant, it becomes zero. It can be any constant, positive or negative, it becomes zero. So that's why I'll get the same answer. That is why we would not do this. See, we don't put x value over here and then definite integral. No, we don't use definite integral. Why? Because of this constant problem. That's why when if you're following this shortcut method, which I'm telling over here, please make sure you use the x value in the given question and do definite integral to the answer, so you will get the exact value. Now this is the correct answer. You can try this over with any of the problems. See, wherever there's definite integral, it's directly in the calculator. Or if there is problems like this, you can follow whatever I just now told you, or you can directly use the calculator. If you want cot, cosecant, I've already done videos on those. Please watch the previous videos. Please watch the shortcut videos. Now, if you're thinking, how do we do this? Very simple. Instead of cot, you have to put 1 by tan x the whole squared. That's the only thing. Just remember, use sine. Now, see, cosecant. Cosecant is not there in your calculator, but we have sine. It's equal to 1 by sine. So just remember to put this in the calculator and solve. So these are the methods. If you want the actual methods how to solve, it's over here, detailed explanation. Please do solve them by yourself and then check for the answers. I will now go through all these answers. You can pause the video and watch it. I'll go slowly through these. So these are the steps. So over here it's done. Definite integrals are very simple in calculator, so you can use that, or you can use the formula. It's the same thing. Now these are all the answers. Now remember, for secant you need to use 1 by cos if you're using the calculator method. Over here you can see these answers. You can pause the video over here if you want to know these, or you can find the presentation from the link as well. So these are all the answers. I hope it is clear, and if you have any doubts, please do put them in the comments section, and I will be back for the next video. Now we move to the 19th topic. It is again on integration and trigonometry. It is considered to be one of the most trickiest topic because it's not that easy. You need to assume and all that. Now, for example, over here this is related to sine inverse. The formula, you have to assume sine thetas and then rearrange this and then solve it. You might have come across this in the regular classes. This is the all long method, but the best part is you can do the shortcut method over here, and it is in the question number 19. You will have the 4 options, but now the problem is you might be confused on how to do the shortcut. Now over here in such problems, when it's definite integral, it's very easy. But look over here, they're asking which form. The form, you must remember the forms in the formula, and based on that you need to simplify these. Now I won't go in detail of that. I'll directly tell you the shortcut method over here. Since secant and tan comes, it might be tricky. See, cosecant comes. How will you exactly solve it directly? Let me take one of the most difficult one, like the last one, because there is a lot of inverse and everything in this. Sorry, let me take this and show you how to solve it directly. You will have 4 options, and I've already checked this. I've checked a couple of problems randomly, and they will definitely work in your calculator. I mean the physical calculator, not just the one I have in my computer. Even the physical calculator, it will definitely work, but make sure you use the brackets properly. If you do even a simple error, you will get a wrong answer. Now you can see secant inverse. Before I start the calculator method, there are a few things you must remember. You know secant equals 1 by cos. But do you know what is secant inverse of, say, x equal to? Now this is not 1 by cos inverse x. It doesn't make sense because the domain is defeated. I mean, it will be error because when you take 1 by cos inverse, all the domain doesn't match. So what happens is you should just remember secant inverse will be directly cos inverse, but whatever is there inside this, what is there? That will be, that's x, right? That will be 1 by x. So now, for example, over here we have secant inverse x by 2. Take a minute and solve what's it going to be. It is going to be cos inverse, it'll be 1 by x, so it'll be 1 divided by x by 2. It'll be 1 divided by x divided by 2. So this is the method. Now then, what we will do is we will see the calculator method. The first step is to take a x value. Now look over here, there is a square root function. Remember, you can't take anything less than uh, 2. 2. You can't make it a negative value, right? You can't take 2. So take a bigger value which makes the above positive. So let me just take 4. No, let me take 4.5 simply. You can't take 0 or 1. You can't take 0.5. It'll give you an error over here. So let me take x of 4.5. X is equal to 4.5. I can take 2.5 as well. It's up to you guys. You can just take a random value, but make sure you will get an answer. Now square root, let me just do the fraction. Square root of 4.5 square minus 4 divided by 4.5 square. What is the answer? It's 2 root. Let's write the decimal form. So the answer is 0.19906. Okay, this is enough. Now you need to definite derivative of the answers. So press shift and dy by dx. Type the answers as it is. It's not a big thing to type. See, natural logarithm. Okay, open the bracket. This is the already open. Now open one more bracket and write alpha x by 2. So it's 2. Make sure you're typing. Once you open, close it. Okay, that is done. Only now natural logarithm bracket is remaining. Now plus tan. All very straightforward. It already opened the bracket, it's fine. But now remember, you're dealing with secant inverse, not 1 by, it is cos inverse. Now use 1 divided by whatever is there. It is alpha x again divided by 2. Now close the bracket properly. And that's for this degree. Now even close the tan bracket and then also close the natural logarithm bracket. I'll just show you what happened. I open one bracket for natural logarithm. So this is closed. Tan was opened and again degree was open. So there were 3 open brackets. So there are 3 closed brackets. The last one is for the definite integral. So leave it. Minus sign. Why I'm concerned about the bracket is if you don't close the bracket or open the bracket properly, you won't get the answer. So that's why right now be vigilant on the brackets. Now sine, it'll all automatically open the bracket. Again, secant inverse is cos inverse. And then what do we have? 1 divided by alpha x divided by 2. Now, if you just press once like this and close, it's going to be wrong. You need to press come over here and then close the bracket and then close the sine bracket again. Now that's it. Don't write the c because it doesn't make a difference. What is the x value? It is 4.5. Let me press equal to. The answer is this. Now obviously when you do it in your calculators, which I did that time, it took a long time, not long time. It took me about 20 seconds, I guess, or 15 seconds. I started counting till 5, but then I just dozed off and then I got the answer. 10 to 15 seconds. So wait, don't press anything, don't press on or anything. Just give it time. It will definitely come. This will be very easy, very quick. You will directly get the answer. But when you're solving the definite integral, it will take time, but you will definitely get the answer. So this matches. Now, you need to be not very quick. If you're going to solve this, it's going to take much more time. So if you do the direct method and find the answer, it's going to be much quicker. So that's fine. So just make sure you check the answers and it's just try to put these values, especially the secant inverse, tan, accurately. Now, what if it was cosecant inverse? Just use sine inverse bracket 1 by x. Just remember about that. So that is it. That is how you can easily solve the answers for this. And you can check the answers. I will show all the other answers as well. So take your time. You can go through this. You can even try solving these by yourself whenever there is. Oh, see, now for example, this is very easy because there is no problem at all. This is just to type it as it is. Whereas when it is secant inverse or cosecant inverse, then there'll be a difficulty. And over here, make sure when you're solving this, make sure the x value is positive. If you take a x value whenever square root is there positive, then this will be positive, not to worry. Okay, whenever this is positive, even this you do not need to use modulus, just use the normal brackets. So this is all the answers. You can pause it and go through it if you want. And now I'm going from backwards because I did the 30-second problem and then we are going backwards. If it's definite integral, very easy. Just type it in the calculator. You will get the answers. So 21 from here. I hope this is clear. So those were all the answers for the 19th topic. And yes, all these are there. Only to be careful when you get secant inverse or cosecant inverse. That's it. If you have any doubts in the calculator method or anything, please watch the video which is there in the description. And if you have further doubts, please do ask them in the comments. I will get back to you as soon as possible. The 20th topic is the last topic in part 2, and it is similar to the previous topic which we had seen in part 1 on separable differential equations. It's just that here you have an extra step of integrating it. So if you have not watched the first video, please go back and be thorough with the separable differential equations. This is topic number 10, I believe. So be thorough with it, and then this will be very, very easy. Here you have a function y dash equals 2 by xy plus y. Now this needs to be separated, y at one side, x at one side. How do you do it? You need to just separate it, very basic. Remove the y common out. So y is out, x plus 1 remains. Take the y to the other side, you will get y dash equals 2 by x plus 1. Next, you need to, now look over here, y dash is dy by dx. So substitute that value. Dy by dx, in this dx term, take it to the other side, and this is the separated differential equation. Now over here you get y dy 2 by x plus 1 dx. Now it's not over. Over here you need to find the solution by integrating on both the sides. Because there is dy and dx, you can integrate both the sides. The left side with respect to y because of dy, and right side with respect to x because of dx. All you do is integrate it, not differentiate, integration over here. You get y squared by 2 equals 2. Now whatever is in the denominator comes up. Natural logarithm of x plus 1, and this is the first constant. This is a constant of integration. Now look carefully over here. What you're doing is you're removing this. Always we write equations in terms of y, isn't it? So remove this 2 to the other side. Multiply 2 throughout. It's gonna be 2 2 times 2, that's 4. Natural logarithm of x plus 1 plus 2 times c1. Now this constant of integration is basically multiplied by 2. Does that make a difference? No, because it's a constant. It doesn't matter what constant it is. It can be 10 times 220. Still, it's a constant. So it doesn't matter. So now 2c1 is just a constant. So write it as c. That is it. That would be your answer. Oh, sorry. It's not over. There is y squared. You need to have in terms of y. So take square root on both the sides. Here you get plus or minus square root of this particular term. That is the answer. Now let's look into some other problems. Now here, same like what we have done just now. Separate these equations. Over here, what you need to do is take the y. See, this entire term goes to the other side. This is y. And over here, x is there. Now, remember, y dash is dy by dx. So it will be dy divided by dx. Dx goes to the other side. This is separated. Now, integrate on both the sides. When you look at this, you can remember it is sine inverse. Now, over here, okay, first of all, the left side, one second. The left side is very simple. It is sine inverse. It's okay till over here. But anyways, the right side, you can't directly solve it. Now, the thing is, you need to do u substitution. Now, it is done in detail over here. What happens is, you take u as natural logarithm of x, and then when you solve, when you derive u, this cancels, that x cancels, yeah, the x cancels. Why? Because you will get du by dx is 1 by x. Take x to the other side and get everything in terms of dx. Now over here, what happens? Dx is x du. Look, you substitute dx value as x du, and here in the denominator, x remains. But what is natural logarithm x? That is u. So you just cancel this x and x. Now you can easily integrate it, isn't it? It will be natural logarithmic u. So that's the thing. And over your left side, it's sine inverse u because it's 1 divided by root of 1 minus y squared. That is sine inverse. If it was x, it would be sine inverse x. Now it's it's y, not u, it's y. So sine inverse y. Now plus c is the constant of integration. It is not over. You need to take sine on both the sides to remove this. Now, okay, that's not yet over because u is not substituted back. Now it is natural logarithm of natural logarithm x plus c. Now take the sine to the other side, you will get the answer. Why? Because it's sine inverse. Take sine on both the sides, sine and sine inverse cancels, and you're remaining with sine. This is the final answer. So over here, sorry, that has been repeated by mistakenly. So that's the answer. It's the same thing. So similarly, you can solve the other problems. Okay, is there any problem? Yeah, that's it. This is the correct answer. So make sure you differentiate it and then you integrate it. That's how you solve it. Please do these by yourselves because we have done this already. We have done the separation, and then only extra part is the integration in the 20th problem. In the part 1, we have already done the separation of x and y. So here are the answers. You can look through it. They're very straightforward. Only thing is you need to be thorough with differentiation and integration. See, there are places over here you can rearrange and write. It's simple. Just go through it and you will understand it. Just be thorough with integration properties and also only the basic integration properties. And also if it's like this, you need to understand, okay, this is sine inverse. Or if it is now here, it'll be tan inverse or not tan, sorry, it's natural logarithm. You should know them. So remember, learn all these properties, basic properties, and then you can easily solve it. But first step is always separate them and then integrate on both the sides. So these are the answers. That's it. So that is the end of the part 2. I hope it is helpful and you're going through them. If you have any doubts, put them in the comments. I will try to get back as soon as possible. Now, in the next part, we will deal with the part 3, which is the writing part. Stay tuned. And if you're not yet subscribed to my channel, please do subscribe to it and do like my videos and share it with your friends. Thank you.